Welcome back, guys. You'll be happy to know that this is the last lesson, the last new material that you are going to learn for the entire year. All we have left is a quiz and a test, and then you're done with calculus for the year. So we're going to end off with the best part, substitution and definite integral. So putting everything of integrals together that you've learned so far. The key to this is when you do u-substitution, you end up with u and du. Well, right now they've set up your integral limits in terms of x. So the trick here is that when you do u-substitution and it's a definite integral, you have to change your limits of the integral to match with u. And I'm going to show you how to do that with some examples. So let's look at number 1. They have us doing the integral from 0 to 5 of x over x squared plus 10. So I'm going to choose the denominator to be u, and that means du dx is 2x. I'm going to rearrange this problem so that dx is by itself. So du equals 2x dx divide by 2x. So I have that. The next thing I need to do, and this is the new part, is I need to change my limits. So what I'm going to do is I'm going to evaluate u of 5 and u of 0. So that's 5 squared plus 10, which is 35. And then I've got 0 squared plus 10, which is 10. So now I'm going to go back to my integral. I've got the integral now, instead of from 0 to 5, I'm going from 10 to 35. And then I'm going to substitute these two items in. So I've got x over u times du over x. Well, what happens is the x's will cancel, and now I've got the integral from 10 to 35 of 1 over u du. Well, the integral of 1 over u is natural log. So I've got the natural log of u from 10 to 35, which is natural log 35 minus natural log of 10. Now you can leave it like this unless your homework tells you it wants a decimal. So if it does, you just type that into the calculator to get a decimal. And so that's all we've got that's new. All you have to do is use substitution like we've been doing in the last section. And the trick is changing the integral limits. Now when you guys did your quiz, some of you forgot to back substitute once you finish taking the integral. Well, you don't have to worry about that here because you're doing a definite integral. Let's look at this example. I'm going to let u equal 5 minus t. So du dt is negative 1. Rearrange that so that dt is by itself. So I have dt equals du over negative 1. So the next thing I need to do is redo my limits, because right now my limits are in terms of dt, which I forgot to write, but I need to make them in terms of u. So I'm going to do u of 1 is 5 minus 1, which equals 4, and u of negative 4, which is 5 minus negative 4, which is 9. So now I have u and I have dt, so I'm going to do some substitution here. I've got from 9 to 4 of square root of u times du over negative 1. Well, right now my integral numbers are out of order. I need the smaller one on top. And you learned in the last section that you can flip those if you put a -1 out front. Well, that works out nicely because now the -1s cancel and I don't have to worry about them. So now I have this integral here, the integral from 4 to 9 of square root of u. I'm going to change that to be u to the 1/2. And now I can take the integral. Well, u to the 1/2, you add 1, u to the 3/2, and multiply by 2/3 from 4 to 9. So I've got 2/3 times 9 to the 3/2 minus 2/3 times 4 to the 3/2. So we're going to type this into our calculator. I've got 2/3 times 27 minus 2/3 times 8. So that is 18 minus 16 over 3. And then you can type that into your calculator and you'll get a decimal answer if you want one. I'm going to leave it like this for now. Let's take a look at another example. From 0 to 2, 1 over 2x plus 4. So I'm going to let u equal 2x plus 4. So du is 2. And I'm going to move du to the other side, or dx, sorry. And so I have dx equals du over 2. The next thing I need to do is, since I'm turning in terms of u, I need to change my integral limits. So I'm going to do u of 1 is 2 times 1 plus 4, and u of 0 is 2 times 0 plus 4. So that equals 6 and 4. And now I can do my substitution. The integral from 4 to 6 of 1 over u times du over 2. And then I'm going to bring out the 1/2. So I have 1/2 the integral from 4 to 6, 1 over u du. Well, the integral of 1 over u is natural log. So I have 1/2 natural log u from 4 to 6. And we can type that into our calculator once we plug this in. We've got 1/2 natural log of 6 minus 1/2 natural log of 4. And you can leave it like this or type it into your calculator to get a decimal answer. We've got another u substitution problem here where it's e to the x squared. So I'm going to let my u equal x squared. So du dx is 2x. Isolate dx. 2x dx divide by 2x. And I also need to change my integral limit. So u of 1 is 1 squared, which is 1. U of 0 is 0 squared, which is 0. So in this case, they get to stay the same. And now I can plug all this information I have into my integral. So from 0 to 1, x e to the u du over 2x. Well, the x's cancel, and I can take the 1/2, think of that as like a 1/2 out. So 1/2 integral from 0 to 1, e to the u du. Well, the integral of e to the u is just e to the u. So I have 1/2 e to the u from 0 to 1, which is 1/2 e to the 1 minus 1/2 e to the 0. Well, e to the 0 is 1. So I'm going to go ahead and change that. 1/2 e to the 1 minus 1/2 times 1, which is 1/2. and I'm going to leave it like this. Again, you can always type these into your calculator to get a decimal answer. I'm not doing that for right now. All right, we've got one more example that we're going to do, and then you guys are going to have some practice problems to work on. This one looks a little scary, but it's not that bad, I promise. I'm going to let u be this inside. So u equals x squared plus 1. So du dx is 2x. Isolate the dx. And we also need to change our integral limits. U of 1 is 1 squared plus 1, which is 2. U of 0 is 0 squared plus 1, which is 1. So I've got new integral limits from 1 to 2. My 32 is still there. Now I've got u to the 7th x du over 2x. So here's what cancels. Your x's cancel, and this 2 will cancel with some of the 32. So now I have the integral from 1 to 2 of 16 u to the 7th du. And we can take the integral of u to the 7th. That is u to the 8th over 8. And you got your 16 still there from 1 to 2. Well, 16 over 8 simplifies. So now we have 2u to the 8th from 1 to 2. So this is 2 times 2 to the 8th minus 2 times 2. 2 to the 8th is 256. And 2 times 256 is 512. So we've got 508 is our final answer. Don't forget, you can rewind and rewatch some of these examples if you need extra help. And as always, come to my office hours if you need extra help, and I can work out some more examples with you. Have a great week.